All right, so here we've got a nice situation, slightly unrealistic, but good enough still to analyze what's going on here. We have a batter standing beside home plate, and then the ball is thrown towards the home plate along a path that can be modeled by a linear function. Of course, the ball is going to curve a little bit because of gravity, but if you throw a ball fast enough, it does sometimes look pretty much like a straight line. So we'll just suspend disbelief here for a second. So the ball is coming at this path right here. I know, by the way, useless information for this problem, but I know that it was thrown from a point that was 2 meters high. So that's the release point is 2 meters high because that's the y-intercept, and I can see a negative slope, so that's why the ball is traveling down. And what that slope means is that for every 1 meter closer, it gets 0.045 meters lower to the ground. And so the first question, what we're going to do is look at whether or not the ball is a strike and the value of A. So the value of A is just basically how much does the ball decrease in height while it's traveling over home plate, which is 0.43. Well, the slope tells you the change over one step to the right. So remember that the slope is always your change in y over your change in x. And you can think of that as how much does your uh, y value change for one step to the right. Well, if we have a change of 0.43 and we are curious about this is our change in y, we don't know that, then what we can say is that our slope, negative 0.045, is equal to the a value that we don't know divided by the change in x, 0.43. In other words, and maybe this might be more intuitive to you, if you multiply the slope by the x distance, then you're going to get the change in the y. That's what slopes meant all along. This is a key fact that some people don't get down, is that the slope tells you how much the y value changes. And so if you multiply the slope by how far you've moved left to right, then you know how far you've moved up and down. So we can take our slope, negative 0.045 times 0.43. We get this wonderful value right there. So that means that the A value is negative 0.01935. Okay. So what we need to know is we need to know whether or not this is a strike. And so we are given up here that it's a strike if it's between 0.53 and 1.24. Now we have the A value, and we know one more clue. They tell us that when the ball reaches the front of home plate, the height above the ground is 1.25. So this point right here is something, comma, 1.25. And we know that this point over here is something, comma, we know the A value is how much it changed. So we just do 1.25 and we add our A value or subtract that 1.01935. So we get 1.23065. So answer it for yourself. Is that a strike? It is a strike because it's less than 1.24. So because 1.23065 is less than 1.24, then it's a strike. So really that question was just asking you to read carefully and understand what slope means. Slope means how much does the y value change for every 1 unit that you move in the x value. So if you move more than 1 unit or less than 1 unit, you just multiply the slope by your change in x, and that will give you your change in y. And you can understand why that's true just from looking at what our slope means again. Slope is change in y divided by change in x, and that's equivalent to saying change in x multiplied by slope is the change in y. And there we go. All right. Then Sakura hits the ball, and now it travels like a parabola, which we might expect because that's how things work with gravity. And he hits the ball according to this wonderful equation. Maybe he calculated it just for funsies after he hit the ball. Now, the distance and we're asked if the ball will go over the wall. The wall is 96 meters away, and that is a d value. And so we're just going to plug 96 in for d right there, plug 96 in for d right there, and see what happens when we type it all in to our good old friend, the calculator. Oops, if you type it in right. So I typed all that in right there. You can check if I typed it in correctly. I get 8.34. So what I know is that h of 96 is 8.34, and that's bigger than 5. Why does 5 matter? Because it tells us in the first sentence that the wall is 5 meters high. So Sakura hit a home run. I guess I'm making an assumption that the wall he hit it at is the home run instead of being like a foul ball, but it sounds more fun to write home run than foul ball, so we'll call it good.
That was graduation.
So